Okay, good morning, students. Am I audible? Am I audible?
Yes, sir.
Visible? Yes?
Yes, sir.
Okay. In the previous class, we discussed about the simple VHDL modules or VHDL programs, and we ended with this particular program for the circuit shown on the screen. We have written a VHDL program for this particular circuit shown there on the screen. So we'll proceed further, and we'll try to write one or two more programs before we go to the second part of this module, that is latches and flip-flops. As I said, in this module, we are discussing in the first part about the VHDL and in the second part about latches and flip-flops. So before we discuss about the latches and flip-flops, today we'll see 2-3 additional programs, and then we can study those latches and flip-flops, right? Now we'll write one more program. All of you can write down, try to write this program. Write a VHDL program for full adder. Write a VHDL program for full adder. Right. So this is the statement given. You have to write a VHDL program for the full adder. Okay. So how do we go about this? How we can write the VHDL code for this? I hope the screen is visible. I have given you the block diagram of the full ladder, wherein I have shown 3 inputs. What are the 3 inputs shown here? Yes, a full ladder will have 3 inputs and 2 outputs. So the 3 inputs here are denoted by what? Yes. Just read what are the signals written there on the. Yes. What inputs we have shown for the full adder? Yes. So here we have 3 inputs, X, Y, and C in. That is, X and Y are the 2 single bit input, and C in is the input carry. Right. And then we have shown 2 outputs, sum and C out, that is carry out. Sum and carry out. For this, we have to write a VHDL program. So you know that what is the relationship between the inputs and outputs for the full ladder? How do you write expression for sum and carry? If the inputs are X, Y, and C in, and the outputs are sum and C out, how do we write the output equations for sum and carry? What is the equation for sum? Yes? You people, are you there or no? I am asking something. What is the equation for sum and carry? Yes? Fine. So can anybody tell me expression for sum here? If you know the expression very easily, you can write the VHDL code for the full ladder. And once you write the VHDL code for the full ladder, we can write it for the parallel adder too. Right? So what is the equation for sum for a full ladder? It is
X XOR Y XOR C in.
Yes, very good. It is XOR operation of the 3 input X, Y, and C in. X XOR Y XOR C in. That is the expression for sum. And what is the expression for carry? Yes. Expression for carry is what? It is sum
XY
of
plus
XY plus Y
plus Y C in plus C in X.
That is, normally I think you are used to the signals ABC. If you take the inputs as ABC and output sum and carry, you write sum as AX or BX or C and carry as what? AB plus BC plus AC. Now here inputs we have denoted by X, Y, C in, and output we have denoted by what? Sum and C out. So easily we can write the VHDL program for the full ladder. In fact, this is also an important program. If you see the previous question paper, it has appeared in the previous question paper saying that write a VHDL program for a full ladder. So you should be able to write that. Okay, so how do we start now? What I should write first? From where I should start? Yes? I think I will just stop this screen so that you can see the board clearly. I hope a board is visible clearly. Yes? Is board visible now?
Yes, sir.
Okay, so how do we write the program for VHDL? From where I should start? First I should write what? Yes? Tell me from where I should start, how I should write the program for VHDL program for full ladder. Always VHDL program should start with keyword what?
Entity.
Entity.
So I should write entity, then some name. What
Full
name I
ladder.
will give?
Full ladder
Entity full ladder is.
is port.
Next what I should write?
Port
Port,
ABC.
not ABC. Whatever inputs you have shown there,
X, Y, C in.
or we can write ABC also. If I don't want to type that particular, say X, Y, C in and sum and C out, if you don't want to write, if you want to write ABC, no issue. I write ABC, fine. A, comma, B, comma, C, colon,
In bit.
in, bit, then
Semicolon. Semicolon.
and
Sum.
I can write sum,
Carry.
carry, colon,
Outbit. Outbit.
output. Fine. I will not take that whatever I have shown there. And then I should write what after this? After this, what I should write?
And full ladder. Full ladder.
And full adder. And then you should put the semicolon. Who is joining now? You people should join on time. Right. Okay. Right. Next, what I should do? I think till this point, everybody has understood, no issues. How we should write the entity. In the entity, you have to declare only the inputs and outputs of that particular design. So I have declared A, B, C of type input or mode input and type bit. When I declare it of type bit means it can take single value either 0 or 1. Similarly, sum and carry of mode out and type bit, so that they also can take only two values, that is either 0 or 1. Clear? Next. Next, what I should write?
Architecture.
Yeah, architecture, how it should start? It should start with the keyword architecture. Fine. Next.
Of full ladder.
Architecture. What? Maybe some name. You can give some name to this. I write arch adder or architecture underscore full adder FA. Architecture underscore FA, then of
Full ladder is
full adder is. Architecture, you give any name. I give an arch underscore FA of full adder is. Next.
begin.
Next, begin. If you need any signals and all, you have to declare, but here I don't want any signal, so directly I can write begin, and then
Sum is assigned.
sum.
Assigned to.
Assign means what operator I have to write? Less than or equal to. Sum is assigned with what?
A XOR B XOR C.
A XOR B XOR C. So how I should write that? A XOR B XOR C, and then you have to put semicolon. This is sum equal to, and then
Carry.
carry is assigned with. Carry is assigned with what now? A and B inside the bracket, or
B and C,
B and C,
or A
or
and C. A and C.
what?
A and C.
A and C. And then what is written?
End.
And what?
End of full adder.
R underscore FA. This is how we can write the VHDL code for a full adder. I hope it is clear. All of you understood? Anybody who has not understood this? If you want actually to add a delay also here, you can write AX or BX or C after 10 nanoseconds. Then A and B or B and C or A and C after 10 nanoseconds also. If you want to include delay also. So if you don't want to include any delay, then you can write the program like this. So I hope it is clear. All of you understood this? Yes?
Yes, sir.
Any doubts here? If you have any doubts, you can ask. Okay, is clearly visible board? Sohan?
Yes, sir. It's visible, sir.
Visibility is clear now?
Yes, sir.
Yeah, right. Any doubts here? All of you understood this program? If anybody is having any difficulties, you can ask. Yes? Isha, you understood?
Yes, sir.
Clearly understood the program? If I give you any other
Yes,
program, you should be able to write it. It is simple. Just whatever the normal logic equations you are writing, you have to translate them in the VHDL syntax. That's all. Clear? Understood? Prajwal?
Yes, sir.
Right. So then, can you write one more program, all of you? All of you should write the program. Now write a VHDL program for 4:1 mux. All of you, try it fast. Write a VHDL program for 4:1 mux. I want you people to write a program for 4:1 mux. Do it fast. What is 4:1 mux? You should know first. And then for that, easily you can write the program. So here is the block diagram of 4:1 mux. You can see it on the screen. I hope all of you getting it on the screen.
Yes, sir.
Yeah. I have given you already the block diagram of 4:1 mux, and you want to write the VHDL program for this 4:1 mux. Right? I want all of you should try it, and you should show your code to others also. Maybe you can write it on the paper, take a photo and share it so that everybody can see it. Because if you hold it in front of the camera, the visibility may not be good. Write the program on the piece of paper. You just take a photo and share that photo using present now option. Do it quickly, because I want you people to write one more program, modified program for that mux also. First write the normal program using data flow modeling style. That means in terms of equations. Then other modified program, I'll tell you how you can do that. Okay, how do you start it? From where you should start now? What you should write first? All of you should write it. You write entity mux is, entity mux is, then next what you should write? Port, what you should write inside the port? Yes, what you should write inside the port? I given you entity mux is, then port what?
I0, I1, I2, I3.
Okay, you write I0, comma I1. Don't write it as a suffix because it is an identifier name. You know that you can't write I and
Yes, sir.
suffix I0 and on. You can write I0,
I0,
comma
I1,
I1, comma I2, comma I3, comma A, comma B. Why I am including all? Because all these six are what? Yes. All these six signals which you have shown, I0, I1, I2, I3, A and B are all input signals. So you can club all, or you can write separately also. But anyhow, all are input. You can write it very easily in one line. That is I0, comma I1, comma I2, comma I3, comma A, comma B, colon. Colon, what you should write? What you should write?
In bit.
Yes?
In bit.
Colon in
In bit.
space bit. Okay, then semicolon. Then semicolon, and after that, what you should write?
F colon out bit.
F colon out bit. F colon out space bit. Okay. So all of you have written the entity. Then after that, you write end mux. After completing the parenthesis, you have to put the semicolon. Then you should write end space mux and again semicolon. Okay. Next, what you should write? Next, what you should write? Next,
Architecture.
architecture. You can write arc underscore mux. Architecture arc underscore mux of
Mux
of
forest
what?
lines. Mux forest
Of mux is. 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 Then what you should write next? Yes.
So we can use select.
No, I am telling first to write data flow modeling style. Then we'll go to that next. That's what I said. I want VHDL program for mux using data flow modeling style. When it is asked using data flow modeling style, compulsory have to write the code in terms of the equations. Is that clear? So arc underscore architecture arc underscore mux of mux is begin, and then you have to write a single statement, single signal assignment statement. Can anybody tell me what is that statement you need to write? Yes? What you need to write? The single statement that you should write is, yes, Soundarya, what is the statement you should write? Soundarya,
Sir, in conditional statement.
not conditional. I said simple signal assignment statement you have to write. We'll see that next, how to make use of the conditional statement. Yes, Richa?
Process.
No, that's what I am telling. Simple statement. Simple concurrent signal assignment statement you have to write. Only one statement is sufficient.
So A bar B bar I naught plus that way.
Huh.
A bar B bar I naught plus A B bar I1 plus A bar B I2 plus A B I3.
But okay, that is the normal equation. You have to translate that in VHDL syntax. Correct.
Sir,
How do you
A naught
translate
and
that in VHDL syntax? Yes, Sridhar.
A naught and B naught and I naught, or A naught and B naught and I1.
A naught and B naught, how you can do? A naught B naught means you can't write A naught B naught. A and B only is there. No? How do you write A naught B naught?
Not A and not B.
Yes.
And I naught.
Yes. Right. So here is the statement that you should write. I hope it is visible. What is that statement you have to write? F is assigned with first what? Not of A and not of B and I naught. So it is like A bar, fine. Then B bar and I0. Similarly, you put it in one bracket, or not of A and B and I1, or A and not of B and I2, or A and B and I3. This is how you can write the VHDL program. And after this, just you have to write end arc underscore mux. Only one statement is sufficient to implement 4:1 mux. This type of modeling style is called as what? What type of modeling style it is?
Data flow.
This is called as data flow modeling style. This is called as data flow modeling style. Right? I hope all of you have written this code. Anybody has not understood anything here? If you have not understood anything, right, you can just tell me. All of you understood it? Yes or no?
Yes,
Yes,
sir.
sir.
Okay. Right. I am getting a response only from 1 or 2 people. I don't know others what they are doing. Okay, fine. We'll move ahead. Now I want the same code. Whatever you have written, you have to write the VHDL code for 4:1 mux using what? Selected signal assignment statement. Selected signal assignment statement means which statement? There are two statements I have told in the previous class. Conditional signal assignment statement and selected signal assignment statement. So which is conditional signal assignment statement and which is selected signal assignment statement? Yes? Conditional signal assignment statement is nothing but when else statement.
Yes, sir.
When else statement is called as conditional signal assignment statement. And which is selected signal assignment statement? Which is selected signal assignment statement? It is, yes, with select statement. With select statement is called as selected signal assignment statement. And I have told you to write the VHDL program for the same 4:1 mux using selected signal assignment statement. So what change you should do in this program? Everything remains same. Whatever this statement you have written, this is the statement, single equation you have written, this has to be deleted, and in place of this, what you have to write now? With select statement. So how we can write that with select statement is shown here. I hope it is visible. Are you getting? So whatever that equation you have written inside the architecture part, just you have to replace that by this. So you have to declare before that in the architecture you declare one signal select. How we should declare that signal select? Yes. In the architecture, before you write this, in the architecture part, what you need to do? You write the keyword signal, then write SEL colon, what you should write? SEL colon what? Because it is a signal which is not there in your entity, so you have to declare it. So how you declare it? You should declare it as what? Bit underscore vector what? 1 down to 0. Why I declare it as 1 down to 0? This is compulsory. You have to declare in the declaration part of the architecture before the beginning, because select you have not declared in the entity. So I have used the keyword signal, then the signal name as SEL colon bit underscore vector. So I am declaring it as a bit vector. If you declare bit, it can take only one value, but we want select to assume two different values. So I have declared it as bit underscore vector 1 down to 0. what that 1 down to 0 indicates? 1 down to 0 indicates the size of that particular array. 1 to 0 means what? 0 and 1. So you can have select of 1 and select of 0. So it is a 2-bit vector. Similarly, if you want to declare it as of say 4-bit, what you could have written there? Suppose if you want select of 4-bit, how you would have written that? Bit underscore vector 3 down to 0.
3 down to 0.
Okay. So in the architecture part, you have to write this first, then you write begin, and then write select is assigned with A and B. What do you mean by that select is assigned with A and B? Because up to this, you will be writing begin of the architecture. Once you write the begin of the architecture, there I said you have to write this. Select is assigned with A and B. What this will do? What this statement will do? We are writing the architecture. Okay, I'll write here complete architecture for your reference. Once again, I'll be writing architecture ARCH underscore mux of mux is right. Then before begin, you have to have this signal assignment statement. The signals declaration, you have to do the signal declaration, then the keyword begin, and then we can write the actual code. So I have declared the signal SEL and I have assigned A and B. So here AND is called as what? Concatenation operator. It is concatenating A and B values. Suppose if A is 0 and B is 0, what value select will take? Yes. If A is 0 and B is 0, what value select will take? Yes. If A is 0 and B is 0,
I0.
select value will be 0, 0. Right? So after this, what you should write? This is the first statement. Then you have to write what? You can see here with. You have to write what is called as with select statement you are using. With signal. With SEL select. With SEL you have to write select. Right? With SEL select what? With SEL select you have to write that F is assigned with what? I0. When you should assign F with I0?
0, 0.
When what? When this SEL is 0, 0.
0.
So you have to write it in double quotes. If it is more than one value, you have to write in double quote. If it is a single value, you have to write it in single quote. So we have assigned that, then you have to put the comma, and then you can write I1 when what? 0, 1, comma I2 when what? 1, 0, I2 and comma I3 when what? 1, 1, and lastly you have to put the semicolon. That is the end of that with select statement. And then you can write what you can write? End ARCH underscore mux. Right? I hope it is clear. With select, you can have this select A and B, then with select F is assigned with I0 when 0, 0, I1 when 0, 1, I2 when 1, 0, I3 when 1, 1, and then end of the mux. The same, whatever is here, I have written the complete code here. The entity remains same. So you have to write that entity mux is for I0, I1, I2, I3, A, B in bit and F out bit, and this will be the architecture. I hope it is clear. Any doubts if you are having, you can ask me, because this particular program of multiplexer you have to execute in your laboratory also of this particular subject of analog and digital electronics. Is it clear? All of you understood this?
Yes, sir.
Yes. Any doubts?
No, sir.
No, good. So shall we proceed further? We'll write one more last VHDL program. Right? This is also important program wherein you will be using the concept of what is called as component instantiation and component declaration. Right? I hope all of you have understood the full adder program which we have done. There is there on the board. Any doubt in that full adder program?
No, sir.
Okay, so now we'll see how we can use that full adder program to write the program for the parallel adder. I hope all of you know the parallel adder. What do you mean by parallel adder? Yes. What do you mean by parallel adder? So parallel adder is what? Full adder adds 2 single bit number along with the carry, whereas parallel adder can add 2 multi-bit numbers. For example, suppose if you call a n-bit parallel adder, then it can add 2 n-bit numbers, and it will give you sum as n-bit, and there may be a end around carry also. So now I want all of you should write a VHDL program for 4-bit parallel adder. At least I want you people to write the entity part. I will tell you how we can write the architecture part, because every VHDL program will have 2 components or 2 parts, entity part and the architecture part. So I want you people to write the entity first. So to write the entity, what you should know? If you want to write the entity of a particular VHDL program, what you should know or what information you should have to write the entity? Yes, what you should have?
Input
Number
and
of
output.
Input and output.
Yeah, you should know how many inputs are there, how many outputs are there. You need not bother how those inputs and outputs are interconnected. That care you will be taking when you are writing the architecture. So when I say 4-bit parallel adder, can anybody tell me how many inputs it will be having and how many outputs this particular parallel adder will have? 4-bit parallel adder. Yes. What are the inputs and output? Number of inputs and outputs it will be having. Yes, Kiran?
2 inputs, sir.
Only 2 inputs. Or how many bits inputs now? Okay, I can consider it as 2 inputs, but every input should be of how many bits? Yes? Because you are writing the code for 4-bit parallel adder. Since you are writing the code for 4-bit parallel adder, you should have 2 4-bit numbers as the input. And there may be input carry, which can be considered as 0 or carry in. And then we should have 4-bit sum, and there should be 1 single bit carry out. All these should be there in the block diagram of this particular design. So I will give you the block diagram, and using this block diagram, I want you people to write the entity. So block diagram is visible there. Is the block diagram visible for all? Yes or no?
Yes, sir.
Yes. Is it visible or no?
Yes, sir.
Okay. If it is not visible, I'll take it here. Okay. At least I have to share the screen again. Window. Yeah. Is it visible now?
Yes, sir.
Yes. What I do is this part I will remove. Yeah. This is the block diagram of a 4-bit parallel adder. So what you can see here in this, if you observe this particular block diagram of a 4-bit parallel adder, you can see that it is consisting of how many? It is consisting of how many full adders? It is consisting of how many full adders? You can see here, full adder 1, 2, 3, 4. So there are 4 full adders. And you can see now what are the inputs and outputs given. What are the inputs to the any full adder will have how many inputs? If you take any full adder, we already discussed the full adder example. Any full adder will have how many inputs? Yes. If you take any full adder, you can see here every full adder will have how many inputs? You can see in this
Three
what
inputs.
here I have denoted them by like X, Y, C in sum and out. That means now what I am doing is to write the VHDL program for a 4-bit parallel adder. Such 4 full adders we are using, and every full adder will have 3 inputs and 2 outputs. So how those 3 inputs and 2 outputs are interconnected here, that is very important. So the first full adder has inputs what? What are the inputs to the first full adder here? Actually, we have 2 inputs. A, which is, I can write it as like A is nothing but A3, A2, A1, A0, and B is nothing but what? B3, B2, B1, B0. Now you need to add these two, and when you add these two, you are going to get the sum, that is yes, and this sum should be equal to what? S3, S2, S1, S0, and there may be carry out. C out you have to consider, and at the beginning there may be what? Carry in also. There will be carry in. That's what is shown. I hope it is clear. I have 2 4-bit numbers A and B. These 4-bit numbers are having A3, A2, A1, A0. B is B3, B2, B1, B0. When I add these 2 4-bit numbers along with the input carry, I will get 4-bit sum and a single bit carry out. So the 4-bit sum is denoted as S0, S1, S2, S3, and the carry out is denoted as C0. So you can see here, this Ci is the input carried to this particular circuit, and C0 is the output from this particular circuit. So what we need to do is, first we need to add A0, B0 along with Ci. When I add A0, B0 along with Ci, I will get sum as S0 and intermediate carry C1. Then A1, B1 and C1 you should add to get S1 and C2. Add A2, B2, C2 to get S2 and C3. Then add A3, B3, C3 and get S3 and C0. This is what we need to do. I hope the block diagram is clear of parallel ladder. Any doubts here? All of you getting it or no?
Yes, sir.
We have to add 2 4-bit numbers A and B to get the 4-bit sum and the output carry, and the input carry is denoted by Ci. So how many full adders we are using? 4. So whatever the full adder code you have written, use that full adder code 4 times. It is like calling the function. You have to write a function, like in the high level languages you write a function and you can call that function any number of times. So here full adder program we have already written. That full adder program we can call 4 times. That means here we can't call it as like a function, we have to call it as a component. So that full adder component we have to instantiate 4 times in this particular case. So first I want all of you should write the entity, right? So for this you have to write the entity. Yes, anybody written? Entity. Do it fast. You need to write the entity. Someone should write the entity and you should show me how that entity can be written. Anybody written the entity? Yes. Have you written the entity? Yes, who will tell me what is the entity? I will check who all are there. Yes, Karthik. Karthik, are you there?
Yes, sir.
Yes, can you tell me what is the entity part? How do I write the entity?
No, sir, I am not.
You are not there in the class. Your mind is somewhere else.
No, sir.
Hmm?
Trying to write, sir.
If you are not understood, you should ask, no? Yes, Sahana, can you tell?
Entity parallel adder is
Okay.
port
Hmm.
A comma
Yes.
um, semicolon colon
Yes.
in bit.
Hmm. A in bit you are declaring. Now here A and B are the inputs, right? How these inputs are of how many bits?
There are 4 bits.
4 bits. So can you declare them A as a bit or what? A should be declared as a bit or something else?
I don't know, sir. I have no idea.
No idea. Yes. Next. One more, Sahana.
Yes, sir.
Yes. How do you write the entity?
So entity parallel
Okay.
is port A, B, S, colon,
How you can club A, B, and yes, madam? A and B are input. Yes is the output. Both input and output should not be clubbed in single, no?
A, B, colon, int
A
bits.
comma B you should write, not A,
A,
B.
comma, B,
A comma B
colon, int
colon
bits,
in
bit,
bit. It should be declared as bit or something else. If you declare
Bit
it as a
vector.
bit, no, then A and B can take only one single value, that is 0 or 1.
Bit
But you want A to take how many values? How many bit values? Yes,
4
Sarah?
bit values.
4 bit
4
values.
bit.
Then how we should declare it then?
Bit underscore vector.
Vector. Then inside bracket, what you should write? Correct. You have to write the size. No, it is like declaring the array. What you should write?
3 down to 0.
3 down to 0. S. Next. Yes, Sahana, continue.
S,
No, first write all inputs. There is one more input you have to write. What is that? Yes, what is that input? There is one more input which you have to write. What is that? See, you people, I think you are not understanding. I'll give you this code here. Right? So entity adder 4 is, right? 4, you can see here, I have written the entity adder 4 is 4 A comma B colon in bit vector 3 down to 0 semicolon Ci colon in bit. Why I am declaring this Ci as in bit? Because it is how many bit? I have written here, no? See here, Ci is single bit, A is 4 bit, B is 4 bit. These are inputs and these two are the output. So we have two 4-bit input and one single bit input. Then we have one 4-bit output and one single bit output. So how I should write that in the entity? You can see here is entity adder 4 I have given, you give parallel whatever is. Entity adder 4 is 4 A comma B colon in bit underscore vector 3 down to 0 and Ci in bit semicolon S out bit vector 3 down to 0 and then C out what? C out what? Out bit. Then end adder 4. I hope everybody has written the same entity. Any doubts here?
Yes, sir.
Is this clear?
Yes, sir.
Okay. Next, what we need to do is we have to write the architecture for this. So how we should write the architecture? architecture you have to write using structural modeling style now. This modeling style is called as structural because you are using structure of full adder to implement 4-bit parallel adder. So you will be using this as a component, and that component 4 times you are going to instantiate there. So what I should write in the architecture now? I should write architecture, right? Structure of adder 4 is architecture structure of adder 4 is. You can see from here now. Architecture structure of adder 4 is. Okay, now you have to declare the component before you start writing your what? Before you start writing your architecture, we have to use that full adder as a component. So component declaration you have to do here. How you do the entity declaration? Exactly in the same way component declaration is done. You can see here component full adder, then port XYC in bit, C out sum out bit. That means you are writing description for this component. So component full adder port X comma Y comma C in colon in bit, then C out comma sum out bit and end component. So after declaring the component, we have to write the architecture for this. Before you write the architecture, we have declared all A, B, Ci, C0. But what about this C1, C2, C3? Because intermediate, there are 3 more signals, C1, C2, C3. So what I should do about that now? That I have to declare by using keyword signal. So you should write signal C colon bit vector 3 down to 1. When I write 3 down to 1, I get C3, C2, C1. If I write 3 down to 0, you will get C3, C2, C1, C0. But I don't want C0, so I have written it as C3 down to 0, so that I have C3, C2, C1. So I will get this C3, C2 and C1. So for that purpose, I have declared a signal which is of 3 bits. The next important part is what now? The architecture. So in the architecture, what you have to write? Can anybody tell me? Final architecture you have to write. So that will start with what? Begin. And inside the architecture, what you have to write now? The component instantiation statements, the port map statements you need to write. And these are the port map statements that you need to write. Right? So that port map statements, what we have written here are shown. I have written the code here. You can see the how of the code. Begin you have to write. After that, FA0, right? Then FA1, right? And then FA2, full adder 2, full adder 3, right? So if you do this, you can see here now. Begin. So first full adder you are calling, this full adder you are calling, it is like calling the function. Full adder you are calling with what values? A of 0, B of 0, Ci, C of 1 and S of 0. That means this you are calling with these inputs and outputs. Similarly, you are calling FA1, A1, B1, C1, C2, then FA2, FA3, and by calling or instantiating this full adder 4 times, we have completed the structure of this particular full adder. So this type of modeling style is called as structural modeling style. I hope it is clear. All of you understood this, right? It's not that difficult or not easy also. If you have understood the concept very easily, you should be able to write the code. And here is the complete code. Whatever the code I have given, the same code is, complete code is shown here for the 4-bit binary adder, right? So once again, entity adder 4 is, we have declared A and B of 4-bit signal, Ci is single bit, yes 4 bits, then C0, then architecture structure of adder 4 is, we have declared the component, we have declared the signal C, and then 4 copies of that component full adder we are instantiating to complete the structural modeling style of the 4-bit parallel adder. So any doubts here? All of you understood this? Can you say at least yes or no? If not, just
Yes,
try to write this program once again. You sit and write, or you can just go through the complete program and try to understand the why each signal is used, how those signals are interconnected using the component, and that gives the complete structural modeling style of 4-bit parallel adder. Okay, right? This is what like a 4-bit parallel adder simulation is shown. Now a lab experiment is there. As told as a homework, you try to write this. Write a VHDL code for 8:1 mux. It is there in your laboratory experiment. Write VHDL code for 8:1 mux. You do it as a homework, right? Then write VHDL statements that represent the following circuit. Circuit is given, you have to write the VHDL statement. First write the normal expression and then write statement for each, like what is F, what is G, what is N, and what is I. Write statement for each gate they said. So how do you write F here? F is what? Not of A and B and C. Similarly, G is what? Not of E and D. Then N is what? N is what? F XOR G, and I is not of N. That is the first one. And in second, you have to write the single statement for whole. So how do you write? I equal to not of what? This term we have to get A bar B C XOR D E bar. Right? So you have to start from the reverse, and you can write a single statement for I. So you need not write what is F, what is G, what is N. Directly you have to write I in terms of A, B, C, D, E. So that can be written as I equal to not of, inside the bracket, one more bracket, not of A and B and C XOR not of E and D. Bracket complete, bracket complete. So like that, you can write a single statement. Then draw the circuit represented by the following VHDL statement. How do you write? F is assigned with E and I. All this together, you can have a single circuit. H is equal to first F, I, then A and B. H is not of C and D. So easily you can write the circuit from the VHDL code. So all this you should do it as a homework. And that completes the first part of the module 4, that is introduction to VHDL. In the next class, we'll be starting with latches and flip-flops. So before we close for the day, if you are having any doubts, you can ask. Right? So again, I am telling you need to practice, and then only you will be comfortable with this simple VHDL programming. Again, don't get confused or tensed like hearing the word programming. Very little programming here actually. Whatever the equations you are writing, you are just translating those equations in the VHDL syntax. That's all. So any doubts, Akanksha?
No, sir.
Okay. Yes, any other doubts? If you have, you can tell. Otherwise, we'll close for the day.